Alright, so now we're trying to find the derivative of natural log of root x squared minus 1. We want to find y prime, right? If you guys recall, right, if y equaled natural log of u, right, then y prime was equal to u prime over u, right? So, alright, let's try a different color. Blue's a little hard to see. We need to find what is u, and then what is u prime. Well, we could let u equal this x squared minus 1 to the 1/2 power, right? Then u prime would have to equal, right, we got to use our power rule and chain rule here. We get 1/2 x squared minus 1 to the negative 1/2, right? We just subtract 1 from the power. But now don't forget, right, we've got a chain rule in here because we've got something other than just x in the inside. We've got x squared minus 1, so our derivative for x squared minus 1 is the 2x. Okay, so now I know u prime, I know u. I could just rewrite it in this form. That's all it takes. So y prime then is equal to u prime. Well, let's simplify it, right? The 2 and the 1/2 reduce, right? So those guys are gone. Then I've got x over root x squared minus 1. If you guys recall, the negative 1/2 just simply places this in the denominator. The 1/2 power is the same as a square root. Okay, that's u prime, right? But now I want to put that over u. What was u? That was our x squared minus 1, but to the 1/2 power, we just put it as a square root. And now in this form, it's not too obvious what to do next. Notice if I just put this over 1, now it's a fraction. Now I've got a fraction divided by a fraction. So to divide a fraction by a fraction, we just multiply by the reciprocal of the denominator. So this becomes x over root x squared minus 1 times 1 over root x squared minus 1. Notice we have the same base to the same root power, right? If we multiply a square root by a square root, basically we just get that thing to the 1 power. So this becomes x over x squared minus 1 to the 1 power, right? 1/2 and 1/2. So now, okay, this is y prime. There's our derivative. It seemed like a fair amount of work. Did you guys notice any easier way to do this? You guys may have seen an easier way to do this if we use our log rule, right? Notice this is log of root x squared minus 1. We could rewrite this as y being equal to natural log of x squared minus 1 to the 1/2 power. Now, if you recall your log rules, right, if you had something raised to a power, you could move that out front as a constant. So I can rewrite this as 1/2 natural log x squared minus 1. Now, you might also ask yourself about the domain of this function versus this function. This one will give you imaginary results. This one wouldn't. Okay, we'll talk about domains in a minute. But for now, let's see if we can find its derivative. All right, now, y prime then, right, what do we have to do? Y prime is just u prime over u, right? So here, I need to know what is my u. U here, we could do a u sub of x squared minus 1, then u prime is simply 2x. That was easy. Much nicer than the problem we just did. Okay, so I've got 1/2 times the derivative of this thing. So 1/2 times the derivative of u prime over u. So here's u prime, here's u. So you've got 2x over x squared minus 1. Notice the 2's can reduce, and we get x over x squared minus 1. And then you might ask, where's this thing defined? Right, the original function wasn't defined if we had a negative value in the square root. But this one, also not defined if we have a negative in the square root. Notice where the derivative is defined. Simply x over x squared minus 1. Right, the domain for this function is from negative infinity to negative 1, negative 1 to 1, and 1 to infinity. You guys see why that's true, right? This is basically defined for all values except when we get a 0 in the denominator, right? When is x squared minus 1 equal to 0, right? When x is equal to plus or minus 1. So the domain is everywhere except where it's negative 1 or 1. What about the original, right? That's a little bit weirder. Let's just investigate the domain of the original function real quick. Let's keep that. Let's move that right there. So now the original function, natural log of root x squared minus 1, which was, in other words, 1/2 the natural log of x squared minus 1. Right, what is the domain here? This function, right, it can't be, we can't plug in negative numbers. We also can't plug in 0, right? Natural log of something, right? U has to be from 0 to infinity, not including 0. So, okay, we might ask first, where's that denominator equal to 0? Well, that gives us the plus or minus 1 again, right? So at negative 1 or plus 1, right, it can't be defined. We get a 0. Natural log of 0 is either undefined, or your calculator might even say that it's at negative infinity. But now let's try a test value below negative 1. What if we plugged in negative 2, right? If we plug in negative 2 back into the original, we get a 4 minus 1 is root 3. Nice and defined for all values below negative 1. What if we pick a test value of 2, right, and then plug it back into the original? We get natural log of root 3. Nice positive number, right? That gives us a reasonable result. So then all values above this are also defined. But what about values in between? Well, numbers between negative 1 and 1, right? Notice if you plug them in here, that between negative 1 and 1, those are fractions. Or if we just, picked a test value of 0, plug it into either one of these, you get natural log of a negative number or a square root of a negative number, right? Also undefined. So here it would be undefined. So the domain of the original, right, the domain of natural log of root x squared minus 1, right, has domain from negative infinity to negative 1 and 1 to infinity. So the domain of the derivative can't be beyond these values without going into some space beyond the real numbers. So here, our domain gets limited in other ways, right? The derivative then would simply be confined to these values as well, if not less. So y prime has a similar or smaller domain.